Hello all, welcome to Scientific Facts. In this video, we'll be discussing about free fall and how to calculate the value of small g or acceleration due to gravity. Free fall. Basically, what is free fall? The Earth attracts objects towards it due to gravitational force. When an object falls towards the Earth only under the influence of the gravitational force, it is called free fall. Free fall of an apple. This was how Newton discovered the universal law of gravitation after an apple fell on his head. So if an apple falls to the ground only under the influence of the gravitation force, it is called as free fall. Example of free fall. You may have seen that many people skydive. You may have seen it in movies, etc. When they jump from the airplane, they are only acted upon the gravitational force. Therefore, they accelerate uniformly under the gravitational force. This is a picture of free fall, and only the gravity is acting on the person. So therefore, it is referred to as free fall. Then what is acceleration due to gravity, which is denoted by small g? When an object falls towards the Earth, there is a change in the acceleration due to the gravitational force of the Earth. This is called acceleration due to gravity, which is denoted by small g. The value of g, small g, is 9.8 meter per second square. Therefore, a free-falling body will accelerate by 9.8 meter per every second. So this is a person. He is dropping a ball from the edge of the cliff. At first, the ball is stationary at 0 seconds, and for each and every second, it travels by 9.8 meters. It accelerates by 9.8 meters. How do we derive small g is equal to capital G into capital M into small m by r square? We all know that from the second law of motion, which we will be doing in the upcoming videos. But basically, it's F is equal to ma. We all know that from the second law of motion that force is the product of an object's mass and acceleration. Let the mass of the object be m. We also know that there is an acceleration caused by gravity on falling objects, and it is denoted by g, small g. We have been discussing this through the entire video. So for this chapter, F is equal to mg. Therefore, the magnitude of the gravitational force, F, will be equal to the product of mass and acceleration due to gravity, which is denoted by g, as we saw in the previous paragraph. F is equal to mg. Since F is equal to capital G into capital M into small m by d square, F can be replaced by mg. So we saw that F is equal to mg. So therefore, the F over here can be replaced by mg. So therefore, mg is equal to the remaining things on the right side, which is the same. So mg is equal to g into capital M into small m by d square, or g is equal to g into capital M by d square. It becomes like this because this small m over here and the small m over here gets cancelled. So the remaining in the left side will only be small g, and the remaining in the right side will be g into m into by d square. Where capital M is the mass of the Earth, as we saw, mass of the bigger object, and d is the distance between the object and the Earth. Now let us consider an object to be on or near the surface of the Earth. The distance d will be equal to r, the radius of the Earth, for objects on or near the surface of the Earth. If it's on or near the surface of the Earth, we should take it as the radius, or else we can stick with d. But now we are doing if the object is present on or near the surface of the Earth. So as we saw, mg is equal to g into capital M into small m by r square, or g is equal to g into m by r square. We just need to replace d square with r square if it's near or on the surface of the Earth. Note: as the radius of the Earth increases from the poles to the equator, the value of g becomes greater at the poles than the equator. The distance between the centers of mass of two objects affects the gravitational force between them. So the force of gravity on an object is smaller at the equator compared to the poles. As we saw in the previous video, we saw that force is inversely proportional to the distance or the radius. So if the radius of the place is increasing, the force will decrease. And if the magnitude of the force increases, then the distance of the radius will be low. That's what it says, inversely proportional. So basically it's just the opposite. For directly proportional, inversely proportional. Value of small g at the equator is 9.780 meter per second square. It is lower than the poles because the radius of the equator is more than at the poles. The value of the g at the poles is 9.832 meter per second square. This is because the radius at the poles is very less compared to that of the equator. How did we calculate the value of g on Earth? We all know that g is equal to g into capital M by r square. Here capital G is equal to the gravitational constant is equal to 6.7 into 10 to the power minus 11 nm square by kg square. Capital M is equal to the mass of the Earth, which is equal to 6 into 10 to the power 24 kg. R is equal to the radius of the Earth, which is 6.4 into 10 to the power 6 meters. It is very important to write down the things which are given before solving the numerical. These are all the given things you're supposed to write. So after we multiply the gravitational constant and the mass of the Earth and divide the whole thing by the radius of the Earth, we get it as 9.8 meter per second square. Thus 9.8 meter per second square is the value of acceleration due to gravity, which is denoted by g of the Earth. Hence we conclude the session with this. Thank you for watching this video. Please don't forget to subscribe, like and comment. Thank you once again.